Okay, so hello, good morning, everyone. Am I audible? Hello.
Yes.
Okay, so
Yes, sir.
okay, only 4 people joined. Okay. Yeah, so we can start the session. Like at first, we'll take your doubt. If you have any doubt from week 1 to 4, like for which you can ask. Any doubt in week 1 to 4? Anyone? Like any question or any mock question you didn't understand, or any conceptual doubt, anything? Okay. Okay, so how many of you attempted the mock test? Okay, so no doubt in from week 1 to 4. Anyone? Okay, so you can watch last session, the revision session, where we have explained the revision slide, and we have also released the mock solution. You can go through it also. Yeah. So, okay, how many of you have watched the week 5 lecture, like first 3 lecture at least?
Sir did not start the week 5 yet.
Week
Due to
5
the
start.
upcoming.
Okay. Okay, let us. So we are not gone through the mock test. Like they can. I'm sharing this thing. So any doubt in this question? Like second, like first question is theoretical question. You can go through it. Like those who are not attempted any mock test, any mock question. No doubt. Okay. No issue.
Sir, I have doubts on a doubt only in, I mean, not only, but mainly in that division operation. That's sometimes a bit confusing when, especially when there are more than one attribute on both sides.
Yeah. Okay. So let us take one example. Like it is in mock test only. I think. That is one, right?
Yeah, correct.
So this you are able to solve, right?
Yeah, here this is easy because there's only one attribute on the right side.
So more than 2 attributes there if they're dividing, right?
Yeah.
Okay, okay. Let me take one example. I think in the slide there are one example. Like
Is there an equivalent SQL statement for division?
Equivalent SQL statement, no. Like we have to form the SQL query for that.
Oh, okay. So there is no direct command or anything.
Direct command is not there.
No, there is the relational algebra equivalent expression is there in the slide. See, for with respect to the division operator, right? So you can convert that into the SQL.
Okay, okay.
Division operation is in the code. Just 1 minute. No. Divide times. Okay. Yeah, here, right? This example you can see. Is my screen is visible?
Yes, sir.
Yeah. So yeah, if there is only one attribute, see S number comma P number divided by P number. If we divide it, we will get S number, right? So what we have to do, we have to check for all the values which is in this B1, like B number, which having the corresponding, like all satisfying all the values from A, right? So for P2, if we want to divide by P2, let us say for S1. So S1 for P2 is there. Yes, P2 is there. Okay, S1 P2 is there. S2 P2 is there. Yes, S2 P2 is also there. S3 P2 is also there, right? And S4 P2 is also there. So the answer of this will be S1, S2, S3, S4. Now, in the case of two tuples like P2 and P4, now we have to check for the combination, like for all the tuples, like for P2 and P4, there must be some same their corresponding value
Combination.
must exist, a combination. Like so, for S1, if we consider S1, we consider S1 here. Do I have S1 P2?
Yeah.
S1 P2 is there. S1 P4 is there. S1
Yeah.
P4 is also there. So S1 will be in my option. Now let us check for S2. S2 P2 is there. S2
Yeah.
P2 is also there. S2 P4 is there.
No.
S2 P4 is not there. Now let us check for S3. S3 P2 is there.
Yeah.
S3 P2, yeah. S3 P4 is there.
No.
Right? So S3 will not come. And check for S4. S4 P2 is there. Yes, S4 P2 is there. And S4 P4 is also there, right?
Yeah.
So answer will be S1 and S4. Now same applies for B3 also. Like let us check for S1. S1 P1, yes, S1 P1 is there. S1 P2, S1 P2 is also there. S1 P4, S1 P4 is also there. Right. So for all the value of B3, we have the corresponding value of S number, right? So S1 will be there. All right. Similarly, check for S2 also. Like for S2, S2 P1 is there. S2 P2 is also there, but S2 P4 is not there, right? So it is not satisfying for all the tuples. Now let us check for S3 also, right? For S3, S3 P1 is there? No. For S3 also it will not satisfy, but it should satisfy for all the tuples like P1, P2, P4. And for S4, let us check for S4 also, like S4 P1 is not there, right? So S4 is also not satisfied. The only answer will be S1. In this way, like for all the tuples in B, like if you're dividing by A by B, so it should have a corresponding value in this particular attribute. So from where this logic comes, like from here. This the how we divide, how this division operator totally works. Like here in the case of our previous example, S number and P number was there, and we are dividing it by S number, right? So let us consider this R and let us consider this S. Now here R minus S means it is P number. We are projecting P number from the relation R. Then okay, wait. So yeah, no, this is R and this is S. Yeah. If you apply this condition, you will come to the same result, right? Then we are applying the cross product with the S itself. So the same logic is applied there also. You can try out this expression by applying this all the three cases, right? P1, B2, B3. You get the same answer.
So if B1 has multiple attributes,
Yeah.
then we look at both together as a combination, is it? So like, for
Yeah.
example, if I have S number, P number, and let's say D number or something.
Here, D number.
Yeah, in that, yeah.
There also D number.
Yeah, and there also D number, for
Yeah.
example.
So D1, D2, and D3. So we have to check for the combination of P1, D1. If this having corresponding value for S1. Like for all the tuples, they should exist value, right? Combination of P1, D1, combination of P2, D2, combination of P4, D3. Like that we have to check. I think there is one tutorial also on division operator. In that we have discussed that one example.
Yes, sir, I would like to add something.
Yes.
So you can generalize this thing S1 and the P1, right? In the A, S1 and the P1, and the B is only P number is, right? So you got the relational algebra, how it is for the two attribute and the one attribute, right? Okay.
Yeah.
Let me show you in this way. Okay.
Yeah.
You should, okay. Just is it visible to you? Okay. So
Yes,
you
sir.
got idea about this attribute. Okay, let's take is R. This has two attribute and S. This is the one attribute. You got idea about this example, right? So if I take this example, extend this thing A, B, C, okay, and S V has the B, C, okay. You want this example, right?
Yeah, correct.
Yeah. So first thing about this is that you have to take the attributes that is not present in this, right? So you can see here, you have to select R minus S some in that. So whatever attribute that is not present here, so you have to select that attribute, right? So that is A,
right,
from R, right? And cross product with this S attribute. Okay. So suppose take an example like that. 1, 2, 2, 3. Okay. And this is it clear to you, right? 1, 2, 2, 3. Okay. And here A, 1, 2, A, 2, 3. Okay. B, 2, 3. Clearly you have the idea. The answer is A. Okay.
right.
So
right.
you have to find using this algorithm, means whatever approach expression, right? So first you have to select pi A from R. So what are that? A and B, right?
Yeah.
And you have to cross product with whatever's the value numbers of tuple has this one. So that is 1, 2, and 2, 3. You have to cross product. Then final value is A,
Yeah, 1, 2, A, 2, 3.
1, 2, A, 2, 3. Okay.
B,
And the
1, 2,
next
and B, 2, 3.
B, 1, 2, and B, 2, 3. Okay. This is the output of this one. Then you have to minus this whole thing from this value, right? That is the after minus the next expression what that given in the slide. That is means this R you have to minus it. So whatever's value present in the R, A 1, 2, okay, A 2, 3, okay, and B 2, 3, okay. So you have to subtract it. So final value is, so cancel out
B1,
the common value. This cancel out, okay. This one and this one cancel out, right? And this value is also cancel out. So you got only one value, that is B12, right?
Right.
Okay.
So sorry to interrupt. So where did this B23 come from? In the middle column.
Which one?
This one.
B23.
Yeah, this one.
This one you have to cross product it. This one and this one. Here expression is
okay.
here.
Sorry. Yeah, got it.
Yeah.
Thank you.
Yeah. And this one R minus A B C. So okay, only one value is there. B12. Okay. So only this expression is there. B12. Okay. So after this final whole expression, you have to select whichever attribute is not present in S from the whole expression. That is, you tell me what is the that attribute that is not present in R but not in S. You have to select from this whole expression.
This whole expression is giving B12.
B12. That is A,
And
B, C. Okay. So you have to, after you have to project only that attribute that is the disqualified value, and that is not present in R but not in S, right? So that is the whole expression means.
That part is confusing. So
Okay,
not present in
That
S.
would be A.
Okay, let me you tell me in which slide it is present, so I can take the screenshot of that expression. Piyush sir, which slide it is present? The expression is
that expression, 16.15, 4.1 lecture.
4.1 lecture. Okay. Just
You can see also there is one example given in the slide, like slide number 20, the same module.
okay. So here you can see pi R minus S. So whichever attribute present in R minus S in attribute A, B, C, and the S attribute is B, C. So remaining is only one, that is A. So you have to project here A. So you tell me what is the output of this one?
It will just be A.
Only B. So this is disqualified value. Okay.
It's a disqualified value. Okay.
Value. So you have to you need the qualified value. So how you get the qualified value? From the R expression, from the R, if you select this attribute and minus from it, means that is also R minus S is also a attribute you have to select. Okay, so this A from R, right? So what, whichever attribute are present in R, so this is A12, A23, and B previously. Yes. So you tell me now, pi A R. So what is the output of this? This is R. Okay. Pi A R.
AB.
AB. Okay. Minus AB minus B. Then what is the final result? The qualified value is A. And you can check also here. 1, 2, 2, 3. And the okay.
Got it.
This second part,
Which one?
after you have pasted the formula.
Yeah, there is one mistake. So this is yeah. Tell.
Yeah. Okay. So this is what it is. Yeah. So after you have pasted the formula, the one which is in bracket is clear. We came to this particular formula which is in bracket that will give us B12. Correct?
This whole thing give you the B1.
B12.
Yeah.
The part which is outside bracket, if you can just explain that. R minus R is giving us A minus B, the first part. Outside the bracket, the first part is giving A minus B.
This
right?
one.
Sorry, AB. It's giving AB.
This one, right?
Yes, right.
So R numbers of attribute in R is A, B, C.
Yeah.
And S is
BC.
BC.
So we
then
get A.
R minus S is only A.
The attribute A and the tuples AB is the result.
Yeah. AB is the result.
Yeah. Now the second part, after minus,
after minus pi A.
Pi A, which would be again AB.
No, how this is the we got this one, right? Whole expression, output of this whole expression.
So attribute A of B12, right? So that will be just
the
B.
Part which is after minus, it's projection of R minus S, right? Is that is the formula, right?
Yeah. R minus S. R minus S is only A attribute, right? So you have to project only A attribute, whichever present in A. So that is B.
So actually, I'm not able to understand this part. Oh, okay. So you are projecting R minus S of that bracket, right?
Yeah, whole thing. So there is one mistake you have. So, yeah.
This is of that bracket where B comes, and then we subtract A minus B. Okay.
Yeah.
Thank you so much.
But even in what is there in the bracket will give you only B, right? It won't be B12 because it's projecting only R minus S.
No. This whole expression. Consider only this expression.
No, so the way, but you're saying it is projection of A, right? So projection of
Yeah,
A will
then,
be only
then
B.
only B. Then only B.
But if cross S means it will also give you 1 and 2, is it? That's what it means. No, I'm just trying to understand the one in the bracket at top, right, on the top. So you have pi, some projection of R minus S, which is basically A.
This one. Yeah.
That is A, right? A. So projection of A.
Okay.
On R. Cross S.
Okay. Right. This is R relation, and this is S relation.
Right.
B, C. Okay, so that is 1, 2, 2, 3. Okay, so what is the confusion in which part? This,
So first, I mean, taking one by one. So it says projection R minus S of R,
yeah.
right? So
So
that is
R minus
projection of
S is
A.
this A. It should be
A. So it's only going to be A and B, correct?
only A and B. So
Right.
after that cross product,
Yes. Okay. Okay. So
S.
therefore, it is A1, 2, and A2,
Yeah.
3, and so on.
Yeah. So you have to cross product it.
Okay. And in the second part,
Yeah.
is projection A,
R minus S is A
right? And comma
and S is B, C. So you can check the pi R means this R itself.
Okay. Okay. Okay.
So you can replace this thing as you can see, simply you can say R.
Yeah.
R. Okay.
R minus S comma, that is R only. Yeah.
Right. So therefore, this will give you B1, 2, and therefore we are taking only B out of it. Okay. Got it. Got it.
Thank you, Pradeep, for this explanation. Just an additional question, what is the interpretation of division in the real world? If we have something in the real world and we divide
Yeah.
with entities, what is the interpretation?
Yeah, let me check. So, shall I erase it? Is it okay to everyone? Right? This expression is clear to everyone, right?
Yes.
Yeah.
Yeah. So, suppose there is one text table. Okay. This has the student ID and this has the course ID. And there is one course table. Okay. And this has the CID, means here present course ID, right? Hence here, this is student ID and the course ID. And the question is like that, find the student ID who took all the courses. So you can see where it is all comes, it means the division operator. So you can simply divide it, this division applies the division operator, right?
Why all will mean division?
Because who took
So
all the courses?
I am thinking in terms of mathematical division, like when we divide 15 by 3, right?
No,
So
no.
why all is coming over here?
No, the division operator we apply when the question is like this. All.
Okay. Okay.
Means whichever course in the course table, all course ID, you if you checks the division operator, right? It compares with the whichever student ID has all this value, right? Previously in this way we check means A1, B1, A1, B2, like this, A2, B3, and A1, A3, B1, right? And suppose this course ID has the B1 and the B2. So question is like that, which find the student ID who took all the courses. So you tell me how to find this thing. Who took all the courses? All the courses means whichever the tuples present in course table, right?
B3 is not present only.
Oh, okay. I forgot it. Right. Okay.
So there is no student who took this
No
course.
student, right? So how if there is one more tuple is present, that is B3.
Then
Then
A1 would be
A1 is the answer.
Yes.
So this is the real world application. How this thing?
Division means all.
Yeah, all.
Fine.
Division is more like partitioning, right? So technically, you could also do a query which has only B1 and B2. So if I want to say, show me all the students who have taken B1 and B2 without B3, right? I could technically call that also a division, right? Because B1, B2 alone, I could see it as a subset of data which I partition by or divide by.
So suppose, let me tell you that thing also. Suppose these two courses offered by the biological department. Okay. And this is offered by chemistry department, right? So what you have tell that that is from the find all the course, find the student who took all the course offered by the biological department. That is B1 and so the B2, right? So for all also come in that situation also.
Right. So in that case, I'm dividing by B1 and B2 alone.
Yeah.
Okay.
Yeah, but here we are applying one more condition, like department equals to biology, right? So we are filtering out first based on that condition, then we are dividing. Means for biology department, those have like we will get the course ID of biology department, and then for all those courses we are dividing from the text table, right? So we are applying one more condition here, department equal to biology.
We are applying a condition to find out what are the courses offered by biology.
Yes. What are the courses offered by the biology? And then for
then
all
we are
the
using
courses,
that to divide.
Yeah. Then we are using for that. Yes.
But still, the answer would be A1 over here, right?
Yeah. So A1 student takes all the courses offered by the biological department.
Okay. See, this is fine. I mean, we have taken B1, B2, B3. It's not necessary that we have to simply divide with something which is present in takes, right? We can also say divided by just B1, B2, correct? That can also be a scenario, right? It is not necessary that we have to ensure that B1, B2, B3, everything is present over there. We can simply say divided by B1, B2. Can that be a situation?
Yeah, tell me what is the B1?
So takes is this, what you have written, and divided by B1, B2.
No, that must be a relation, right? B1, B2.
B2. No.
So we take a view. We make a view and say that B1, B2 is present.
Yeah, for view we are creating, we are giving some name to that, right? For a particular view. So we can divide by that view name. The text divided by that view name. Yeah.
So yeah, we can do it, right? Okay.
Suppose
that
the course view.
Course view,
right. Course view with attribute CID, right?
With attribute CID. And the tuples are B1, B2.
Yeah, that is the same thing only.
That is doable, right? Yeah. Okay.
Yeah. So only one necessary condition is there. So suppose if you write the text division course, right? So whichever attribute present here, so this need to be proper subset of the course need to be proper subset of this attribute. So whichever present there, suppose the A, B, C, D, E attribute present in text. So it should be like this only, A, B, C, right? So it you cannot perform the division of it if it's like E, F, G, right? So whichever attribute present here, it should be present here also, or need to be proper subset.
Yeah. So if it is AB, I cannot think of an answer outright. My question is, if we have the attributes AB in the text table, let's say ABC, okay, and in the course, we have the attributes ABC, and in the course we have C, attribute C, right? So so the answer will be the attributes of the answer will be AB,
Yeah, that
will
is
be
it.
AB.
AB.
C, okay.
Is it clear to everyone?
Yes, thank you very much. Thank you.
Very clear. Thank you so much.
Any other doubt means a mock?
Sir,
Sorry, I
not directly
missed
on
the initial part. I have a doubt in one of the activity question. Is it okay to ask, or how are we moving? I didn't get that.
Yeah, you can ask.
Okay.
Activity 1 to 4, right?
Yeah, activity. Actually, I have a doubt in activity question 4.2. Activity question 4.2. Question number 6 and 7. Am I audible or am I disconnected?
Yes,
You
yes,
got
Okay,
disconnected.
fine.
Activity question 4.2, no? Yeah, that's one.
Yes, 4.2, question number 6 and 7.
So this one, right?
Yes.
Okay. Number 7 is equivalent to A, B, C, D, P, Q, R. A, B, C, L, M, N, P, and Q, R. Yeah, so we are getting all the
I
attributes.
find both 6 and 7 interrelated, and the answers that were coming, I think it was contradictory. So maybe you can explain both the questions, not just the answers, but as a concept, and then it will be clear.
Okay. So what is happening in the question number 6? Can you tell me?
Question number 6, it is clear it is happening a cross join.
Yes.
Sorry, it is happening a Cartesian product. This is very clear.
Cartesian product, right?
Yes. So first option definitely is right. After that, I don't know why it chose the third option.
Yes, 1 minute. My screen is visible, right? This one.
Yes.
Yeah. Okay. So here you can see we are getting all the attributes, right? And here we are not specify any condition also, right? So ABC belong to X table and PQR belong to Y table. So this is a form of DRC, right? Domain relation calculus. So from here we can say we are doing the Cartesian product because we are not applied any condition. If I mention like okay, there is no common attribute, so anyway it will cross join only. So first one option is the correct, right?
Yes.
Now let us check for second one. Here it is all right, so it is not the correct one. Let us see for the third option. For a tuple T, there exists M belong to X. So this is M. There exists N belong to Y. So this is Y. And T dot A equals to M dot A. So we are projecting A attribute here. We are projecting B attribute. We are projecting C attribute. P, Q, R. So we are projecting all the attributes. Like it is equivalent to this DRC query. So whatever we are projecting here, A, B, C, P, Q, R. So in tuple relation calculus, it is a form of TRC. We have to mention like that. For a tuple T, the attribute name equals to any that relation, say S, and then attribute name. So if I want to project any particular attribute from the S table, I have to specify like this in the tuple relation calculus. Like T dot attribute equal to S dot attribute. So here we want
actually in the second option, this T dot small p is equal to N dot capital P. Why
yes.
this small p has come into the picture? Because of this small p, I would not be considering option 2 also.
In second option.
Yeah, it shouldn't. Yeah, in the third option,
Oh,
T
no,
dot
no.
small p. Why is
It
that
should be,
small
it
p
should
over
be
here?
capital. It should be
Oh,
capital.
this was the thing, no?
Yeah.
Even in the fourth option, you see T dot capital P is equal to N dot small p.
No, actually that is
So this actually caused the
typo.
confusion. What is this small p coming about? So it should be a capital P, right?
Capital P only, yeah.
Okay.
Because we are projecting the attributes, right, from the this table.
Yes,
Yeah.
now it makes sense. Fine. And similarly, question 7 also.
Yeah, that's one.
And just a quick related question. So the key difference between domain relational calculus and tuple relational calculus is when we are projecting in tuple relational calculus, we'll just simply put a T instead of all the different attributes, individual names of the attributes, right? In domain relational calculus, we individually write it as A, B, C, D, A, B, C, D, and so on. Is that the main difference or there is more to it?
Yes, that's one. Okay, say suppose for example we have one table, say R, and we have say attribute A, B, C, and we have tuple say A1, B1, C1, A2, B2, C2. So in tuple relation calculus, the query will expression will work on the tuples right here. In the case of domain relation calculus, the expression will work on the attribute and domain variable. Right. So in DRC, we are like this is the equivalent query for the DRC. Is for a relation R, there exists ABC which belong to R. This should be in the same order which is present in the relation R. Instead of ABC, I can also write PQR here, but that PQR must be in the same order, like PQR, right? And here, same for the relation P also, right? So in domain relation calculus, we specify like this, like for a tuple T, then vertical slash, and then some predicate. And based on this predicate, if this condition is true, it will fetch that particular tuple. And whatever you want, if you want to project like attribute, we have to specify like this, like T dot attribute name equals to P dot attribute name. Okay, so where P is any relation. But in the case of domain relation calculus, we are projecting the attribute here, like in this case you can see a, b, c, x, y, like all the attributes, but that attribute say a, b, okay, so now this a, b, c belongs to R, so I'm only projecting a, b from this a, b, c, R, so I will get only a, b here, right? So whatever you want to project in the TRC, you have to specify like this, and whatever you want to project in DRC, you have to specify by attribute and then separate by comma at a, comma, b.
Right. And both in domain relational calculus and tuple relational calculus, we don't specify the joins as it is, right, between the two tables. So we'll be probably just doing only the direct filtering conditions. Like, for example, if it is a particular type of book or something like that, we just put that as this particular attribute is equal to that.
And condition, no, we
particular
can
the
perform
conditions
join
are-
operator also. Like here you can see, we can do join operation also in TRC and DRC. Like this symbol is used for natural join and this is for cross join. Okay. So in the TRC, if we want to perform the natural join, we have to specify the condition. Like for suppose in this case, we have to specify like this. What is the correct query here? Okay, M. Here R dot, okay, so here M dot B equals to P dot B. We have to specify for joining this because there must be some common attribute to join the table, right? So here you can see we have to specify in the case of TRC, right? R dot B equals to P dot B. Like here, is M belong to R and N belong to P, right? So here, yeah, here you can see we specify that condition. Yeah, M dot B equals to N dot B. So if you didn't mention this condition, then it will perform the cross product. If you mention this condition, then it will perform the natural join. This is in the case of TRC. In the case of DRC, simply we can say, okay, like here A, B, C, and B, X, Y. So here we don't need to specify because we already have the same attribute. But what if instead of B, I use M? So here I have to add one more condition where B equals to M. So
with
this
a different name of an attribute.
Instead of B, if I use M, so I have to specify like this, one more condition, and B equals to M, right?
Okay.
That's the case.
So the key, so I mean, so so in TRC, we are projecting from T to the individual relations plus the joins plus the conditions. Whereas in DRC, we will not be doing the projection joins, like, where we are doing T dot A is equal to M dot A. We don't do that kind of a thing in DRC because the individual attributes are mentioned, but we will be doing joins and we'll be doing conditions.
Yeah, joins and applying the condition back and or anything you can do based on the condition. Yes, Apul. So what was your doubt here?
Yeah, so Piyush, the question number 6 was a tuple relation calculus thing, right?
Yeah.
TRC, right?
So here you have to see which of the
This is domain. This is domain.
No, this is a different question. Here we have to see which result in A, B, C, X, Y. Here you can see B is not repeating here. In the case of cross join, the same attribute will repeat, right? Here it will also come B in the case of cross join. But in the case of natural join, the same column will be repeated once only, right?
Yes, right.
So here this clear by looking at this that we have to perform the natural join, right?
Yeah.
Not a cross join. So I think this is the correct option.
But this is a case of a domain relation calculus or no?
No, in general.
In general, okay.
R natural join P will get this attribute only. If we perform R cross product P, we'll get A, B, C, then B, X, Y. We'll get 6 column. And here we will get 5 column only in the case of natural join.
Yeah, fine.
Here it is equivalent to DRC because we are projecting all the attribute. Yeah, so I think this is also correct. And A, B, C, and X, Y. I think this is also correct, right? So I think
Why option 2?
2 option R minus 2.
No, sorry. Why option 3rd will be there?
Like A, B, C, X, Y. Okay, so whatever we want to project is there. And this A, B, C belong to R and B, X, Y belong to P. Right? So this is the case of DRC, right?
But again, if we look at the previous question number 6, we chose this option when it was a Cartesian product. When it was a Cartesian product, then we chose this option. Now it is a natural join, then also we are choosing this option.
No, see, like here there are 5 attributes, right? In the previous case, it was, I think, 6 attributes. Let me check. Yeah, there was A, B, C, P, Q, R, right? So B was not common there. Here B is common.
Okay, so we are taking this option.
Yeah.
Okay.
So the natural join is automatically assumed in DRC as long as the names are the same. Both B is common.
Yeah, B is common. If instead of B, if I use M, so we have to specify condition like B equals to M. Yeah.
Okay.
Like in the last session, we have explained DRC and TRC. We can go through. Okay, any other doubt from week 1 to 4?
I have one in triggers, right?
You're sorry, I did not understand why 4th option is right. I was going through this particular activity to check what is the right answer, but did not understand why 4th was right.
4th one is the equivalent to TRC, TRC expression. This one, no? Yeah. So for a tuple T, there exists M. For R, there exists and belong to P, and we are specifying the joining condition, and we are specifying like projecting the attribute A.
So
B,
the problem that I am facing is it was the same with Cartesian product also.
In Cartesian product, we are not mentioning this condition. If we didn't mention this condition, it will perform the Cartesian product. You can
but
see
in the Cartesian product also, the option that we chose had this thing condition T dot A is equal to, okay.
No, that was for projecting the attribute.
Yes, got it.
This is for projecting the attribute. But for a tuple T, the T dot A equals to M dot A. But this is for a joining condition, right? Yeah.
M dot B is equal to N dot B. Okay,
From,
fine. Okay, thank you.
If you didn't mention that condition, then it will be a cross product.
A small difference, but crucial.
Yeah.
Okay, thank you.
Yes, Kaushik, right?
Yeah. So just a question on the way triggers work in PostgreSQL, because one of the questions that we had in activities, I don't remember the number, where it says before inserting, for each row,
Yes.
it is basically calculating some bonus salary and then finally getting inserted into the table. But the way the function is written is it says new dot salary is equal to greater than 75,000 or something. Then you calculate bonus like this. But my just to understand how the triggers work, does the trigger have already know that this is the value of salary, this is the value of age, and so on, even before inserting? Because the record has not been inserted yet, but it is still calculating the bonus, right, based on some call to the trigger.
So while defining the
I'm
trigger,
trying to understand how.
yeah. So while defining the trigger, we have to specify the event, like before insert or after insert. So that trigger, if we define it for a before insert statement, like insert, update, or delete, we can specify any of this event. Like so, whenever we are trying to insert any particular record, that trigger will get executed, right, automatically. The trigger will get evoked, right?
But before inserting, will it have the values in its memory? So, like for example, I'm inserting. Let's say I'm inserting employee ID and salary, right? And in the trigger function, I say that if salary is greater than 75,000, then add a bonus of 1.25 into salary, right? And that's the function I've written. Now, when I'm doing before insert, will it have it in memory that I'm trying to insert? My insert value is so and so employee ID and the salary is 80,000. Will that have it in memory, and therefore it is calculating bonus from that? I'm just trying to understand how the trigger works, because after insert I can understand, because you can always say after insert you go and update the bonus because you already have inserted the record. Before inserting a record, how does it know what is my salary amount?
No, so okay, let me start. You are talking about practice question, right?
Yeah, correct. That's correct. Yeah, practice question, and in fact I think it's also in grade.
This one, right?
Yes, this one.
So here you can see define a trigger for update event, right? And after update has happened. Right. So whenever we update any employee a table, we get the new. So we have defined that okay, new dot e salary greater than 75,000, then counter equals to counter plus one.
Like if you look at the graded assignment, sorry, the same thing, graded assignment has a similar one, but it does it before insert, I think.
Okay, graded assignment.
Yeah, this one, yeah.
Yeah, so this before insert, yeah. So we have defined this trigger for a insert statement, like for before occurring the insert statement, right?
Yeah.
Yeah. So whenever we
the E department, yeah. Sorry, go on.
Sorry. Yes. Yes.
It says the function says new dot E department is R&D, then E bonus is equal to E salary into 0.75. So on insert, we are just, so I'm assuming that when we are inserting into employees, so all we have put in there is this 4 RD, Diksha and all that. But the record is not there in the table yet because this trigger is getting initiated before the insert itself.
Yeah.
Piyush sir, I would like to add something. Yeah. You can see the new is a variable in which we store all the information that you want to insert. The 4 RD, this RD value and the Diksha and the 30, right? So that is stored in the new variable. So here you can check in the bonus fund in this function. First new dot department, check if the value is R&D r/d, then it increase the salary, and that value is again updated the E bonus value, right?
Okay, so this new dot E department is like a in-memory variable or something where it's basically on insert, it will just keep it there.
Yeah, before, if you want to insert something before that is not in the table and you want to refer that thing, then we use the new. And if you want to delete, right, so that previous value is referred as the old value.
Old value.
Yeah.
Old value. Okay.
In the case of update or
if I put old, it is what is already existing in the table. Is what old
yeah, already. You want to delete something, and suppose if you want to take count or something before delete, you want to back up something like that, then you refer that value as the old value.
Okay. Okay.
Yeah, please, sir.
Just for update and delete, we use the old value, right? Before update or after update.
Okay. Okay. Okay, sir. I think that's clear. Thank you.
Okay, any other doubts from week 1 to 4? So today we plan to take first doubt from week 1 to 4 and then week 5 session, but a very few numbers are there, so maybe we can arrange one more session.
Piyush, Pradeep, is it doable 2 weeks in, I mean, the last date to submit everything for week 5, 6 is 12th now. From your experience, is it doable in 1 week, the study material of 2 weeks?
Yes, like we have released the week 5 content like last Friday only, right?
Yeah, but given this particular examination was there, at least I did not study week 5 anything.
Yeah, but we have extended the deadline also for week 5.
Yeah.
Like it's for all the, it's same for all the courses, right? It is doable, yeah. We'll plan one extra session, like we'll take 3 sessions, so we can cover all the topics from both the weeks. Yeah.
I have one more question. I promise it's the final question. Just for clarity on exists versus in, so another where we say select query so and so and so with a condition, and then say exists, and then we have a subquery for it. Can you just provide a little clarity on the difference between exists in some, just for one? I mean, if you've already done it in a previous session, I will probably go look at that video. So I don't want to waste your time, but just trying to understand, because I sometimes get confused between some exists and in subqueries.
Okay. Let me share my screen. Okay. My screen is visible, right? Hello.
Yes.
So you want to know about exist and
Some. SOME.
Yeah, some. Then
some and no SOME. There's some, right? So look for
okay.
some of the records.
Yeah. Okay, some.
And in, you have in, right?
Okay, yeah, in. Okay, so.
And is there all? There's one more.
N1 is not exist, right?
Non-existent, of course. All of this, I think there is a negative also. Except for some, I think there is a negative for all of it.
Okay. So in exist operator, if the subquery returns at least one record, then it returns true, right? If the subquery, sorry. So let me explain in PGLM, that will be helpful. One minute. My screen is visible. Hello.
Yes, sir. Yes.
So basically, so let me take one by one. That will be help. So basically, in operators, so if you want to avoid multiple use of or operator, then we can use the in operators. So but basically, suppose if you want to test some list of value that matches or not, then we can use the in operators. Suppose the question is find the student ID. We have taken course ID CS101 or CS347. So if you see the text table, let's see the text table. So if you want to find the student ID, we have taken course ID CS101 or CS347. So in that case, what we can do? Select. We have to find a student ID. So ID from text where course ID in CS101, then CS347, right? So
Where?
sorry.
Where?
Oh yeah. Sorry. So in that query, you can also write in the without the help of in operator. So you have to write multiple times or operator, like select
Yeah. So course ID or
yeah ID from text where course ID course ID equal to CS101 or course ID in like this course ID 347. So like this. So you have understood in operator, right? Hello.
yeah, and as an extension, we can also do in a subquery, right?
Yeah,
Say
in
course ID in some subquery.
yeah
But
in
what
sub
here is I have to equate only one field. I mean, I'm looking at one attribute in something. That's what
yeah.
Okay.
If you want to match some list of values, suppose these are the list. So CS101, CS3. So if you want to match that this course ID are present or not, then you can use in operator. Right. Okay.
Got
And then next.
Not in is just the opposite of it.
Yeah, not in.
It's
Yeah, not in is the opposite. So then exist operator, right? Okay. So then exist. Okay. Not exist. Yeah. So exist operator, the exist operator returns true if the subquery parts returns one or more record, then it returns true. Suppose if subquery returns at least one record, then it returns true. So let's see one question. Suppose if you want to if you want to find the names of students who have taken at least one course. So let's see the first table. Select star from star. So in the student table, you will find ID, name, department name, and the total credit. And the text table, you will find student ID and the corresponding course ID. Suppose 00128 taken CS347, 12345 taken CS101, and the 1235 taken CS101, like this. So you want to find the names of student who have taken at least one course. So let's write the query. So select. So we want to find the name. So name from student as where exist select star from text t where s dot id equal to t dot id. So this is so you will find the list of students who have taken at least one course. So basically, so for the what happens in the this query, so basically select name from student s where exists select star from text t where s dot id. So we have taken each id and we have compared t dot id means text table t dot id is present or not. If at least one record is present, then it returns true. If it returns true, then it will print the name of the student. So exist
This presents
clause.
a unique name, is it? Because
Yeah,
it seems to be unique.
yeah, unique. So if you see the table, so there is name, so the id and the name, so all the names are unique.
Oh, it's a name them. But if there are duplicate names, there will be duplicate in this query, right?
Yeah, duplicates.
Okay.
So you understand exist clause how this correlated query works. So you got it also, or shall I explain once again?
So I got it in the sense that I'm also doing a join in the subquery itself, because I'm joining the attribute in the main query to the subquery. Okay, that's how it is filtering.
No.
id is equal to t dot id.
Actually, so basically s dot id. So we pick up means all the means pick up one by one id. So suppose, so let's so s dot id. So we pick up 00128 id from the student table, and we see from the text table. So let's that 00128 id is present or not.
Okay.
Then we pick up another s dot id. Then we have from text table we have check that this student id is present or not in text tables. So you got it.
Yeah. So the equivalent other way of writing this query would be to say select distinct from takes the student ID and join it with student, is it? It doesn't work that way.
Yeah, I think no, doesn't work. So let's okay. Yeah. So and the next is
Sum.
not exist. Okay, sum.
Not exist. Yeah, not exist is the opposite of this.
Yeah, not exist opposite. Then the sum. So a sum clause if the subquery part means suppose if the subquery part means if it's true at least one. Let's take one example. You will find the names of instructor with salary greater than that the some instructor in the history department. So in the if you see the instructor table in the history department, you will see there are two instructor, right? One is EI said 32234 and another is row number 8 Califeri, right? So you want to find the names of instructors who have greater than at least one instructor salary from the history department. If the salary is greater than suppose this instructor salary, then it will print, or this instructor salary, then it will print the name of the instructor.
So it is kind of exist only.
No,
if we will write exist, then also we'll get the same result, isn't it?
No, not. See, exist or some are different. So see, exist means if the subquery parts return at least one record, then it returns true. But the sum is the suppose at least one means if the some instructor is greater than the at least one salary, at least instructor in the history department salary. Suppose, see, if you see the let's see, Einstein is physics department. See, his salary is 95,000. So 95,000 is greater than the 60,000 or 62,000. If it's at least one greater than, then it returns the name of the instructor.
Yeah, so I wanted one thing, like exist operator will only check whether that condition is satisfying or not. S dot id equals to t dot id. So if it is not satisfying that condition, that is true, then it will return that particular value, which is in the select operator. But here some we're comparing two values, right? We're comparing the salary here. Like say suppose like salary is 50,000, and then we are comparing greater than sum of, in the sum we have the list of salary, let's say 50,000, 60,000, 40,000. So it will compare the salary with the which are the attribute, sorry, which is the tuples present in the sum clause, right? So we use this for a comparison purpose also, right? Sum operator.
And there
And
is
we can-
also an all, is it?
Yeah, all is also there. Like for all, it should satisfy all the condition, like which is there in the subquery part. It is select salary from instructor. Like for all the instructor, if you want to find out, then we have to use all here.
And there is no not all or not some, I guess.
Not all, not some is not there. Yeah.
Okay.
Any
The
is
all
any,
that is the vice versa, right? Some is the
yeah.
and the all.
Some, okay. Yeah, there can't be negative there.
Not all means some, right?
Yeah, that's correct.
Any operator is also there. Like if any of this, it will satisfy.
Any, yeah, any is the other one. Any is what? Any, what does it do?
Any is similar to the sum, right? You can replace with the sum. Never.
Okay, so salary greater than any can also be returned, sir.
I.
Yeah, and the so and any other things we have clears exist, not exist, some, all. Any other things? Hello.
No, I'm good. Thanks.
Okay.
Thank you so much.
Okay. Any other doubt from week 1 to 4?
Okay. If there is no further doubt, then we can end this session, right? We can. Okay, any doubt?
Hopefully, it's an easy paper.
It depends on how well you prepare, right? Yeah, so for week 2 and 3, you can watch the live session that we have conducted this Monday, right? So we have conducted one separate session for SQL. You can watch that session.
Sure.
It will be very useful for you.
Sure.
Which one? Which session?
SQL practice session. And this Monday we have conducted one session.
This Monday. Okay.
And one session on AR diagram, a week 4 activity session.
Yes. Arup.
Yeah, Arup sir
And
conducted
Arup.
that, yeah.
Yes.
So that two live session are important. Else you can go to the slide and the content, right? Activity, PQ, and DQ. Okay. Okay, then thank you, everyone. Yeah.
Thank you,
so much.
everyone.
Thank you.
Thank you so much. Thank you.
Thank you, everyone.
Thank you.